So now we're going to go ahead and classify the triangle by using the distance formula to find its length. You can also use the slope to find the angle. If it looks obviously acute, you don't have to show anything. But something like this, doesn't it kind of look like 90? Then you have to use the slope to prove it. If it's this obvious, less than 90, then you don't have to prove it, okay? And what else would you do for this one? We're going to find the perimeter and area. So let's start with the perimeter. If you know all the sides, it's easy to classify what type of triangle they are. So is there any easy length that you can find? The bottom one, right? Why? You can just count it. It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So base is 10. What about this length right here? How would you find this length? You can use a distance formula from point A and B. Or, since it's already on the grid, can I just go ahead and make a triangle and use a Pythagorean theorem? Yes. So it's 1, 2, 3, 4, 5, 6. And here 1, 2, 3, 4, 5, 6, 7, 8. Then you can use a Pythagorean theorem, which is kind of distance formula. What they do on the distance formula is they do y2 minus y1 to find the difference, which is 6. They do x1 minus x2 to find this length. Okay? So, do you notice anything? This is what? 3, 4, 5 triangle. Do you see it? 3 times 2, 4 times 2. Then this must be 5 times 2. If you don't remember that 3, 4, 5 ratio, then you can do square root of 6 squared plus 8 squared, which is 36 plus 64. Square root of 100 equals to 10. Right? So that's 10. Oh! So it's 10, 10. What type of triangle is it? Isosceles. And if it's isosceles, we were wondering whether this is 90 or not, right? Can these two be 90? No, right? All three needs to add up to 90, and if they're equal, they cannot have two 90 angles, right? So it is acute, right? Must be less than then. Acute isosceles triangle. So what about this side right here? So here, if I draw a triangle again, it is 1, 2, 3, 4, 5, 6, and 2. What do you need to do? You have to use the Pythagorean theorem. So why did I square root it here? If I call this x, x squared equals to 2 squared plus 6 squared, right? If I'm solving for x, you have to square root it to get rid of the square. That's why I square rooted the first one too. So my x becomes square root of 4 plus 36, which is square root of 40. So let's just plug into the calculator so we can combine with the other two lengths. Square root of 40, 6.325, 6.325, 325. Remember, on the progress check, they ask you to round it to the third decimal. So in class, I'll start practicing with 3 decimals. Most of the keys will have 2 decimals, okay? So now, what do we do for the perimeter? You go around and add them, right? So the first side was perimeter equals to 10 plus 10 plus 6.325, which is 26.325 units. What about the area? How do you find the area of a triangle? This one is nice and easy. Why? You can find the base by counting. You can also find the height by counting. Some other triangles that I'll show you later, will be much harder than this. Why? Because you cannot just find base and height by counting it. So what's the base? 10. What's the height? 1, 2, 3, 4, 5, 6. 6. So how do you find the area of a triangle? It is small b, which is length of the base, times height, divided by 2. So it is 10 by 6 divided by 2, which is 30 units squared. Okay. I'm not going to finish the next question, but I can get you started. So perimeter, it seems like you have to just use a distance formula for all, right? There's nothing that you can just count it. So I'm sure you can do the perimeter. But what about area? What would you do to find the area like this? We can use this as a base, right? But then, can you find the exact perpendicular height? No. So we can now just do base times height divided by 2. What else can we do? There are two ways to do it. You can divide this triangle to two triangles with the horizontal base, but you can only do that if the base is a whole number. You see, it's not exactly finished with this. And what about height? Height, we can get it. Height was 4, even it's outside a triangle. And height is 3, right, for this triangle. But is the base exactly a whole number? No, so we can't do that. If it works, you can do it. So that method doesn't work. What other method can we do? What do we do for the composite figures? Remember, we found the total area, which is easy to find. For this case, it would be a rectangle. And then what? Subtract this triangle, that triangle, and that. That's easy. We have base and height, base and height, base and height. So you subtract 3 triangles from one big rectangle.